Revolution. The movement of the earth around the sun is called revolution. Thus, rotation and revolution take place simultaneously. The earth revolves around the sun in an anti-clockwise direction along a fixed orbit. It takes 365 days and 6 hours to complete one revolution, and this time is considered to be 1 year. You know that there are 365 days in a year, but you must be wondering what happens to the extra 6 hours. For the sake of convenience, we count only 365 days in a year, and after every 4 years, the balance of 6 hours adds up to a day, 24 hours. This extra day is added to the month of February. Thus, every 4th year, February has 29 days instead of the usual 28, and the year has 366 days. Such a year is called a leap year. Effects of revolution. The effects of revolution are variation in length of days and nights, vertical and slanting rays of the sun, occurrence of seasons. Variation in the length of days and nights. Have you ever thought why nights are longer in winter and shorter in summer? The variation in the length of days and nights occurs because the earth revolves around the sun with its axis always inclined at 66.5 degrees. North Pole and South Pole have 6 months long day and 6 months long night. The equator has equal day and night. Away from the equator, the days are longer in summer and the nights are longer in winter. At the poles, the variation is maximum. There is continuous daylight for 6 months during summer and continuous darkness for 6 months during winter. The Earth's axis is always inclined in the same direction. At position A, the North Pole is inclined towards the sun, while the South Pole is turned away from it. During this time, all places in the northern hemisphere have longer days and shorter nights. Places in the southern hemisphere have shorter days and longer nights. The North Pole gets continuous daylight while the South Pole gets continuous darkness. At position B, that is after 6 months, just the opposite happens. Vertical and slanting rays of the sun. The portion of the earth that is tilted towards the sun receives vertical rays of the sun, while the other portion receives slanting rays. Vertical rays give more heat than slanting rays. Can you see why? This is because the vertical rays are concentrated in a smaller area, while the slanting rays are spread out over a larger area. Also, the vertical rays pass through a shorter distance of the atmosphere than the slanting rays. Thus, they lose less heat.